So here's a simple example. Let's say if we want to find the limit as x approaches 2 of the function x squared minus 4 divided by x minus 2. So how can we do so? Well, one way is to use direct substitution. If we plug in 2, notice what will happen. 2 squared is 4. 4 minus 4 is 0. So 0 over 0 is undefined, which we don't know what value that represents. Now sometimes, you could find a limit by plugging a value that's close to 2. And that's what you want to do. You want to plug in a number that's close to 2, but not exactly 2. So for example, let's call this f of x. So let's calculate f of 1.9. And let's see what's going to happen. Actually, let's make it 2.1. So let's get a positive answer instead of a negative one. 2.1 squared minus 4, that's about 0.41. And 2.1 minus 2 is 0.1. So this is going to be 4.1. Now, what if we pick a value that's even closer to 2? For example, let's try 2.01. So if you type this in the way you see it in your calculator, you may have to put this in parentheses. You should get 4.01. So notice what's happening. As we get closer and closer to 2, the limit approaches 4. So we could therefore say that the limit as x approaches 2 of this function is equal to 4. And this technique works for any limit. As long as you plug in a number that's very close to whatever this number is, but not exactly that number, if the limit exists, it's going to converge to a certain value. Now sometimes, you have to use other techniques to get the answer. In this particular example, we can factor. X squared minus 4, you can write it as x plus 2 times x minus 2. Now we need to rewrite the limit expression until we replace x with 2. Now notice that we can cancel x minus 2. So when this term is gone, we can now use direct substitution because the x minus 2 factor was giving us a 0 in the denominator, which we don't want. So now all we need to do is find the limit as x approaches 2 of x plus 2. So now we can replace x with 2, and 2 plus 2 is 4. And so that's the limit. It approaches a value of 4. Now let's look at another example. What is the limit as x approaches 5 of x squared plus 2x minus 4? So notice that we don't have a fraction. We're not going to get a 0 in the denominator. So for a question like this, you can use direct substitution. So all you got to do is plug in 5. So it's going to be 5 squared plus 2 times 5 minus 4. So that's 25 plus 10 minus 4. And 25 plus 10 is 35. So the limit is going to be 31. And so that's it for that example. But now what about this one? What is the limit as x approaches 3 of x cubed minus 27 over x minus 3? Now, if we try to plug in 3, it's going to be 0 over 0, so we don't want to do that. In this case, if you have a fraction like this, see if you can factor the expression. So how can we factor x cubed minus 27? So what we have is a difference of cubes. And whenever you see that, you can use this formula. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So in our example, a to the third is like x to the third, and b to the third is 27. So a is the cube root of x cubed, which is x, and b is the cube root of 27, which is 3. So this is going to be x x minus 3, and then a squared, that's x squared, and then plus ab, so that's 3 times x, and then plus b squared, or 3 squared, which is 9. So now we can cancel the factor x minus 3. So what we have left over is the limit as x approaches 3 of x squared plus 3x plus 9. So at this point, we now can use direct substitution. So it's 3 squared plus 3 times 3 plus 9, which is 9 plus 9 plus 9. Adding 9 3 times is basically multiplying 9 by 3. And so this limit